Hey math kids, today we're going to talk more about extending the properties of exponents to rational exponents, or just exponent rules in general. And so we're going to start with how to go from something in this form, radical form, to rational exponent form. So this is just one example. Really, it's just this goes on top. So the exponent goes on top, and then the root number goes on the bottom. And so if we're given the fifth root of x to the seventh, we just write x, and then the top of the fraction would be 7, and the bottom would be 5. There's really not much more to say about that, so we'll keep moving on. Well, I guess we can look at, this is like a relationship we could use. So b root x to the a. So that's like the general form of that idea. Okay, now on your homework, we have a few problems that look like something like this. Let's see, a to the 9 and b to the 3. And all of this is raised to the 2/3. So the way we want to approach this one is we're going to use the rule where we multiply exponents from the previous video. And we want to keep in mind that these really have an exponent of 1, even though we can't see it. And so we're going to take this 2/3 and multiply it here, 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 and here, or on all the exponents. So, yeah. So what we'll do, we have -8 to the 2/3, 125, to the 2/3, and then let's take these ones out here just a little bit. So we have 9 times 2 over 3, and then we also have b to the 3 times 2 over 3. So I'm going to figure these out real quick. So I'm taking this piece and figuring it out, and then I'll write it down here. So we can do 9 times 2, which is 18, over 3, which gives us 6. And so right here we write a to the 6. 3 times 2 is 6, over 3, which is 2. So we get b squared right there. Now, these, if you have a calculator handy, you can just type it in and see if it ends up being a whole number. If you don't have a calculator handy, though, I'm going to walk you through how to do the math on this. Okay, so I'm just going to rewrite this, and then I'm going to use my my new rule right here, and we're going to square that, and then cube root it. Okay. And overall, this is still going to be a negative number. So think of it more like the negative's just out there. So we have 8 squared, which we could break up into 8 times 8. We're using something I call the tree method. 4 times 2, 2 times 2, 4 times 2, 2 times 2. Now, I know it's kind of hard to see, but we're looking for triples because of this number. So if we get 3 of the same number, and we only worry about the primes, then we can take them all out. So since all of the primes, because if we do 2 times 2 times 2 times 2 times 2 times 2, that equals the same thing as 8 squared, or 64. So that's what we're looking for. Now we take just the 3 and the 3 2's and the 3 2's, take them out, they become a single. Take these ones out, they also become a single. So this entire thing is the same thing as 4, but remember we still have that negative, so we're going to think of it as negative 4. So this piece is this piece. So if we're writing our final answer, we have negative 4, a to the 6, and then we have a b squared on the bottom. Now we just need to figure out this 125. So I'm going to rewrite that as 125 squared under a cube root. And once again, we're not going to square 125. Instead, we're going to just think of it as 125 times 125. Okay, 125 can be broken up into 5 times 25. 5's prime, so we don't do anything. And then 25 is 5 times 5. Okay, now we go up to the root number, which is 3. So we need 3 of the same number in order to take it out. Okay, and so we take out this group of 5's, becomes a 5 on the outside. Take out this group of 5's, comes a 5 on the outside. So that ends up being 25, and that's our final answer on that one. Okay, so moving on to one that looks like this. Now we could approach this one in 2 different ways. What I would do is I would just take the square root of 25, so that's 5, and it's raised to the 1/2. Technically we could leave it like that, or we could rewrite it as the square root of 5. Now the reason why it's the square root of 5 is because all numbers have an implied exponent of 1 if we don't see it, and then a square root is actually the second root, and so there's an implied 2 there as well. So just like when we have 1x raised to the 1 over 1, all those ninja 1's that go on, we have a ninja 1 here and a ninja 2 there. So the final answer we would just write as the square root of 5 on that one. Now the other way you could approach this, so I'm just going to rewrite it. We could change this to 25 to the 1/2. Just be the same reasoning right here, the new rule we started talking about today. And whoops, this was 1/2 and this was 1/2. Okay, we can multiply the exponents. So 1 times 1 is 1, 2 times 2 is 4. Now we have 25 to the 4th, and we write that as the 4th root of 25 to the 1. We do our tree method, so that's 5 times 5, and that can't be broken down anymore because we would need 4 of the same number. Now, if we go to a calculator, I'll show you. So if we go to a calculator, we do the square root of 5. We get that. And then if we do 25 raised to the 1/4, see how we got the same number? So even though our final answers, because this is really just the 4th root of, whoops, 4th root of 25 or 25 to the 1/4, we get the same number. They're all equivalent, they look different, but you can choose to do them either way. Okay, let's move on to another type of problem that you'll see. So we have the square root of 18 times 2 to the 5/2. So what our goal is here is we want these to look like the same thing. Like we want to have an x to the a times x to the b. So we need these bases to be the same. So we're hoping that we can write square root of 18 as something like 2 raised to an exponent. That's our goal. So what we're going to do is just break up the 18. 9 times 2, 3 times 3. There's an implied 2 for the root, so we just need 2 things to pull it out. So we pull out a 3. There's only 1 2, so we'll leave it like that. Okay. And we still have that piece. Alright, so this thing is the square root of 2, or 2 to the 1/2. We're still multiplied by 3. We're still multiplied by 2 to the 5/2. Now, because we have the same base, we have a 2 and a 2, we can use our adding exponent rule. So we're still going to have this 3 out in front, but now we'll add the exponents. So we'll have 2 raised to the 5/2. And we can just stop there. If you want to plug it into a calculator to see what it equals, that's fine, but this answer is acceptable as well. And we're going to do just one more. Let's see. Okay. So, let's see. Let's do 25, a to the 3, b to the 5 over 5, a to the 3/2, b to the 3, and then c to the -2. So this is similar to some of the problems you did on your previous homework, but it's just a little bit more advanced. So since this doesn't have any exponents, we're going to treat it just like a fraction. So 25 divided by 5 would just be 5. Now, we're going to subtract these exponents, 3 and 3/2. So we're going to say 3 minus 3/2. We need common denominators. So if we think of this like 3 over 1, we multiply the top and the bottom by 2. So we get 6/2 minus 3/2, which would be 3/2. So 3 minus this would be a to the 3/2. Okay. Next thing, we combine these. It's also subtraction. 5 minus 3, b squared. And then this is our negative exponent rule. Negative exponents mean we're on the wrong side of the fraction. So we move it up top. We end up with c squared on top. Now, since there was nothing that was left on the bottom, we don't need to create a fraction. And so this would be our final answer. If you need additional help, please come to Math Lab. But for now, calculator.